Chapter 4, problem number 93. A 1.14 times 10 to the fourth kilogram lunar landing craft is about to touch down on the surface of the moon, where the acceleration due to gravity is 1.6 meters per second squared. I'm going to call down positive in this problem. It's at an altitude of 165 meters and has a velocity original of 18 meters per second. So VO is 18 meters per second, and that's down. And it's going to be displaced downward through 165 meters. Right, because it's at a height of 165 meters. It's traveling at 18 meters per second, and a retro rocket is firing, which brings the craft to rest right at the surface of the moon. So the final velocity is 0, and they want to know what the thrust is. Okay, what is the thrust? Now the thrust is directed upward. So we have the weight of the rocket down. We have the thrust up, which is going to be greater than the weight in order for the craft to accelerate and slow it down to rest just before it touches the surface of the moon. So we're looking for a force, so I'm going to jump right to Newton's second law. So we have sigma F equals ma, where the net force, since down is positive, I'm going to say weight, positive, minus thrust, right, that's directed upward, is equal to the mass of the rocket times the acceleration. So the thrust then is equal to the weight of the craft minus the mass of the craft times the acceleration. Now, to find the acceleration, we go to kinematics. The final velocity of the craft squared, which occurs here, is equal to the original velocity of the craft squared plus 2 times the acceleration of the craft times the displacement of the craft. So solving for A, we get the final velocity squared minus the original velocity squared all over 2 times the displacement. Now, the weight of the craft from Newton's second law is mg. So let's substitute. So we have the mass of the craft, 1.14 times 10 to the fourth kilograms. Multiply that by 10 meters per second squared. Subtract the mass again, 1.14 times 10 to the fourth kilograms, and then multiply that by the negative of 18 meters per second squared, all over 2 times delta y, which is 165 meters. Okay, so that's how we get the thrust. Let's see what it is. So I'm going to take 18 squared. That's negative. I'm going to divide that by 2, divide it by 165. I'm going to multiply that by 1.14 times 10 to the fourth kilograms, and that's a negative value. And then I'm going to add that quantity here to 1.14 times 10 to the fourth times 10. And I'm getting a thrust of 125,200 newtons. Is the thrust. Now, does that make sense? The thrust should be greater than the weight. And the weight, I see where I made a mistake. The acceleration of gravity, it's not 10 meters per second squared on the moon. It's only It's good I caught this. We would have had an accident there with that craft landing, probably. It's 1.6 meters per second squared. So let's redo this. So we take 18 squared times 1.14 divided by 2 divided by 165. Okay, and we have a negative here, a negative there. So we're going to add that to 1.6, not 10 meters per second squared, times 1.14. Okay, and I'm getting 29,000, about 400 newtons. Is the thrust. Now, let's take a look at what the weight is. The thrust should be more than the weight. The weight is 18,240 newtons. So this makes sense because we have a thrust that's greater than the weight. So the craft will accelerate upward, which should bring it to a rest on the surface of the moon.